In this lesson, I'm going to show you guys how to work with the unit circle, the special angles, and to use the reference angles to find trig values. Now, a unit circle is a circle with a radius of 1 unit. If you look at the diagram to your left, okay, as you can see, you have a circle with a radius of 1. So this is your radius. It's 1 unit from the center of the circle. Now, because the values of radius is 1 for each point P on the circle, the sine, cosine, and tangent values for theta are defined as the following. Okay, so let's take a look at this right triangle. Okay, so theta is here, so that means this side here is going to be the opposite side. Okay, which is the y, right? The opposite is the y, because it goes up along the y-axis. Adjacent, this side is adjacent, which is the x, and then this is the hypotenuse, which is 1. Okay, so sine theta, we know it's opposite over hypotenuse. Okay, so that is going to be, well, the opposite is the y, and then the hypotenuse is 1, so that's going to come out to y. So sine theta is your y. Now, cosine theta is adjacent over hypotenuse. Well, that's going to be x over 1, and that's going to turn into an x. So cosine theta is the x, and then tangent theta is opposite over adjacent, and that's going to be opposite is the y, adjacent is the x. So the coordinates of P can be written as, so we know it's what, xy, and that could be written as, the x is the cosine, so you can write that as cosine theta, and then the y is sine theta. Okay, so you can write it like that. Okay, so now we're going to get into special angles. So the special angles are the 0 degree, 30 degree, 45 degree, 60 degree, 90 degree, 180, 270, and 360. So those are your special angles. So the following angles are used frequently in the unit circle. So these are the angles right here, and those are your special angles. Okay, so we're gonna use the unit circle to come up with the value for these. Okay, these are really important to memorize because it's gonna come up a lot. It's best that you just memorize these values. Okay, so I'm going to show you how to come up with this. Well, first we gotta change degree to radians. So 0, 360 degree is the same as 0. So we go up to this unit circle. Okay, so 0, 360 is right here. So that means the point is going to be 1, 0, right? So that point is 1, 0. So sine of 0, okay, is going to be 0. Because remember, this is your sine, this is your cosine. Okay, so this is the sine, this is the cosine. So sine of 0 is 0, cosine of 0 is 1. Tangent is going to be y over x, right? So that's going to be 0 over 1, which is going to be 0. And the point we have is 1, 0. Okay, so next we're going to look at 30 degree. So to change 30 degree to radian, you would multiply by pi over 180. So if you multiply this by pi over 180, you are going to get pi over 6. Okay, and then to find sine, cosine, tangent, you need to be looking at the 30, 60, 90 special right triangle. Okay, so here is your triangle. Okay, so this is 30 degree. This is 60 degree. Okay, let's say this is the center of the circle. Okay, this is theta right here. So that means this is going to be 1, the side that's opposite from 30. This is going to be root 3, and this is going to be 2. Sine is opposite over hypotenuse, so this is going to be 1/2. Cosine is adjacent over hypotenuse, so this is going to be root 3 over 2. And then tangent is opposite over adjacent, so 1 over root 3. Rationalize, you get root 3 over 3. This point right here, this point P, is going to be, the first one is your cosine, so that's going to be root 3 over 2. And then the second one is your sine, that's 1/2. Okay, so point P is at root 3 over 2 and then 1/2. So now we're going to work with the 45 degree. So I'm going to do another special right triangle here. Okay, so this is going to be 45 degree. This is 45 degree. So this is going to be 1. This is going to be 1. This is going to be root 2. Okay, so when you multiply this by pi over 180, you are going to get pi over 4 after you reduce. And then sine of 45 degree, it's going to be 1 over root 2. But when you rationalize it, it's root 2 over 2. Same thing here, 1 over root 2. So when you rationalize it, it's root 2 over 2. And then your tangent is going to be opposite over adjacent, so that's going to be 1 over 1, which is going to be 1. Okay, so here your cosine is going to be root 2 over 2, and then your sine is also root 2 over 2. This is your point P. Okay, so what is 60 degree in terms of radian? Well, if you multiply by pi over 180, you are going to get pi over 3. So this is pi over 3. And then your sine of 60 degree. Sine of 60 is going to be what? Opposite over adjacent, right? So sine of 60 degree is going to be root 3 over 2. And then cosine of 60 is going to be 1/2. And then tangent of 60 is going to be root 3 over 1. Okay, which is going to be root 3. So the point here is going to be cosine. So cosine of 60, that's 1/2. And then sine of 60, that's root 3 over 2. Okay, so your point P is at 1/2 root 3 over 2. Okay, so 90 degree. So what is 90 degree in terms of radian? Well, if you multiply by pi over 180, right, you're going to get pi over 2. Okay, so this is an easy one because it's right on the axis. So 90 degree is right here. Okay, so that's 90 degrees. So the point here is going to be what? Well, it's going to be 0 for x, 1 for y, right? Okay, so the x is the cosine, and the y is the sine. What is sine of 90? Well, sine of 90 is 1. What is cosine of 90? So that's going to be 0. And then tangent is when you take y over x, right? So when you take y over x, you are going to get 1 over 0. Well, that makes it undefined. Can't do that, right? Because 0 cannot go into 1. So tangent of 90 degrees is undefined. So here it's going to be 0 for x and then 1 for y. And then these are easy too. 180, 270, those are all on the axis. 180 is on the x-axis, and then 270 is on the y-axis. Okay, so 180, let's take a look at 180. So 180 is right here. Okay, so what is this point? Well, this point is going to be negative 1, 0, right? Let's use the point negative 1, 0 to complete the table here. 180 in terms of radian is going to be pi. Okay, and then sine of 180 is 0. And then cosine of 180 is negative 1. So here you have 0 over negative 1, which is going to be 0. And then the point here is going to be negative 1, 0, right? Okay, and then 270 degrees is right here. So this point P is going to be at 0 and then negative 1. Okay, so this is going to be 0, negative 1. All right, 270 is the same as 3 pi over 2. Sine of 270 is negative 1. Cosine of 270 is 0. And then tangent is negative 1 over 0. So that makes this undefined. So 360 is on the x-axis, right? Now if you want to find sine, cosine, tangent of 360, right here, it's the same as 0. Okay, so this is on the x-axis. So here, which trig functions are positive in quadrant number 1? If theta was in quadrant 1, so this would be positive. So the x is going to be positive. The y is going to be positive because it goes to the right and then up. So anything in quadrant number 1 are going to be positive. So all of the trig functions are positive. Now quadrant number 2, so the x is going to be negative and then the y is positive. So this is your cosine and this is your sine. So the x is the cosine, the y is the sine. In quadrant 2, sine is going to be positive. And then the reciprocal of sine is cosecant. So that's also positive. And then quadrant 3, so here's going to be negative and then negative. So you go to the left and down. So they're both negative, the x and the y. So that means tangent is the only thing positive, because tangent you end up dividing, right? When you take negative, divide by negative, it turns positive. So tangent is positive. And then what is the reciprocal of tangent? Well, it's cotangent. Those are the two trig functions that are positive in the third quadrant. Okay, and then the last quadrant, quadrant 4. Okay, so here you have positive, and then this is negative. So quadrant number 4, the x is positive, and that's your cosine. So cosine is positive, and what's the reciprocal of cosine? Secant. It's also positive. And the best way to remember this is to remember the phrase. And here is the phrase, all students take calculus. So quadrant 1 is all, quadrant 2 is student, so that's S, right? Quadrant 3 is T, which is tangent. And then quadrant 4 is C, which is cosine. So this phrase right here will help you to remember which trig functions are positive in these quadrants. So here's the example. So it says if cosine is less than 0, so that means cosine is negative. Okay, cosine theta less than 0. So that's going to be negative. And then cotangent theta is greater than 0, so that's positive. Greater than 0 is positive. Which quadrant could the terminal side of theta lie? Going back to this right here, guys. Well, tangent is positive in quadrant 1 and then quadrant 3, right? But then you need cosine to be negative. And then cosine is negative in quadrant number 3. Okay, so the answer to this one is going to be quadrant 3. So cosine is negative and tangent is positive in quadrant number 3. So the last thing in this video, I'm going to show you guys how to use the reference angles to find the exact trig values. And then here is the process of how to do it. You get step 1, 2, and 3. Step 1 is to find the measure of the reference angle. And then you identify the trig function for the reference angle. And then you adjust the sign if needed. Okay, so let's take a look at the example here. So here is to give the exact value for each trig function. The first one we're going to look at is tangent of 300 degree. Okay, so we're going to come up with the trig function for tangent of 300 degree. Okay, so first thing we have to do here is to find the reference angle. First, draw a picture of a coordinate plane so that you can easily understand what the reference angle is and how to come up with that. Okay, so tangent of 300 degree, if you rotate here, it's 90 degree, 180, 270, and then 300 degree is somewhere here. Okay, so this is going to be your reference angle right here. So to find reference angle, if you go all the way to this axis, it'll be 360. So if you go 360 minus 300, okay, you get 60 degree. So the reference angle is going to be 60 degree. Okay, so here you have a 60, 30, 90 right triangle, right, to work with. It's the same as finding tangent of 60 degree. The only thing that's going to change is because it's in the fourth quadrant, the sign for tangent is going to be negative. Okay, so tangent of 60 degree is going to be, well, let's see. So this is root 3. This is 1. This is 2. So that's going to be opposite over adjacent. So there's going to be root 3 over 1, which is root 3. But because it's in the fourth quadrant, this is going to be a negative number. Okay, so tangent of 330 degree is going to be negative square root of 3. Tangent of 300 degree is negative square root of 3. Okay, so for this one, if you memorize the table we went over at the beginning of the lesson, okay, if you remember what tangent of 60 degree is, it's root 3, right? Remember that, root 3. But because we're looking for tangent of 300 degree, it's going to be negative root 3 because it's in the fourth quadrant. But if you're just looking for tangent of 60 degree, that's just going to be root 3. All right, let's take a look at another example here. Okay, let's try to come up with cosecant of 7 pi over 4. So this is a radian measure. It's giving to you in terms of radian. Okay, but you can change this to degree if you wanted to. Okay, let's work in terms of radians. Okay, where is 7 pi over 4? So this is in terms of 4. 2 pi over 4 would be right here. Right? 2 pi over 4 is the same as pi over 2. And then here would be 4 pi over 4. Okay, and then here would be 6 pi over 4. And then go all the way back to the x-axis. This would be 8 pi over 4, right? So 7 pi over 4, it's going to be in the fourth quadrant again. So 8 pi over 4, if you take 8 pi over 4, take away 7 pi over 4, well, that's going to give you pi over 4. Okay, so the reference angle here is going to be pi over 4, which is the same as 45 degrees. Okay, so this is pi over 4. So here you have a 45, 45, 90 special right triangle. Now, cosecant is the reciprocal of sine. Okay, so what is sine of 7 pi over 4? Well, the reference angle here is going to be pi over 4, right? Okay, so let's see, what is sine pi over 4? Well, sine pi over 4, we know, is going to be what? Root 2 over 2? Your cosecant pi over 4 is going to be, you flip it, right? Cosecant is the reciprocal of sine, so cosecant of pi over 4 is going to be, it's going to be 2 over root 2. But when you rationalize this, it's going to be just root 2. So 2 root 2 over 2, so that's just going to give you root 2. Okay, so cosecant pi over 4 is root 2, but here we're looking for cosecant 7 pi over 4. So that's going to be in the fourth quadrant. So it's still going to be root 2, but because it's in the fourth quadrant, the root 2 is going to be a negative number. So it's going to be negative root 2.